Everyone, in this video, we will create a machine learning model for diabetes prediction. It's a binary classification problem. First, we have to turn off the warning message, import warnings, and warnings.filter warnings ignore. And we will run this cell first, and we will import some Python libraries, import pandas, import numpy, import matplotlib, import seaborn for visualization. Matplot and seaborn for visualization. We will run this cell. We will read the file and create data frame. Data frame df equal bd.read csv diabetes.csv. This file it's a CSV file, comma separated values. Read the file and create data frame. Data frame dot head, it will print the first 5 rows. These columns are features, and the last one outcome is the target, and we will target this dependent value, and the features are independent variables. We will make exploratory data analysis. df.info to check the information about the features and target, and we will run. It gives me information. This data frame contains 768 entries. Start from index 0 to index 767. And this all the features and the target. And here all features not contain null. Here 768, 768. There is no null values here. We will check the number of rows and columns and use data frame dot shape. The data frame contains 768 rows and 9 columns. We can print also the name of columns, df.columns. This is the columns. We will use describe to give me information about the statistical values for the data frame. It's like count for each column and the mean and the standard deviation and minimum value and maximum value and 25%, 50%, 75%. These values for numeric data. We will make data cleansing. We have to check the null value in data frame. df.isNull.sum. It's zeros for all columns. There is no null value. We have to check also the values 0. 0 also, it's a missing value. We will run 0 counts equal df dot equal 0 dot sum and print 0 counts. This one. The result here means the first column have 1110, but this is not a wrong values. And also outcome contain 500. It's also right value, not wrong. Why? Because the outcome here contains 0 and 1. 0, it means it's a diabetic. 1 diabetic. 0 not diabetic. It's correct. And the pregnancies also contain 0. This is right. But if we have 0 in this columns, it's wrong. It's wrong value. We have to handle it. But here 0, it's okay. And here also 0, it's okay. We have to handle this columns because it contains 5 rows with 0 and blood pressure also. We have to handle it. We can handle it by replace 0 value with a median value. How we can make it? df glucose equal df glucose dot replace 0 comma num nb num by dot median df glucose, the same column. And we will make the same in blood pressure and scan here and insulin and PMI. We will replace 0 by median value for the same column. Median value df blood pressure and also here blood pressure. We will run the cell, and also we have to check if there is 0 values or not. The result here should be no zeros in these columns. But still zeros here and here because it's a right value, not missing value. Here we handle all this. We have also to check the correlation between features and outcome. Outcome is the target. To check the features, we will create here feature columns equal column for column n df dot columns. If column is not equal outcome, because outcome is a target and the all columns is a feature. For feature in features column, which we defined here, correlation equal df dot core df outcome. It will compare each feature with outcome, the target, and print correlation for the feature, this one, equal correlation. We will run the cell. This is the correlation between each feature and the target. All result here is positive. It means it's a positive correlation. We can visualize the correlation also here. Core equal df dot core bl dot figure size 8,4 sns cborn dot heatmap core cpar squared some features for the heat map and print. This is the heat map. It gives me the same result here. Here's the correlation between pregnancies 0.22. Pregnancies 0.2 with outcome. This is the correlation visual map. Now data frame is ready to create machine learning model. We will use support vector machines algorithm to create machine learning model for diabetic prediction. We have to import some library here. Import library, it is not recommended. Already we imported from scikit-learn.model import train test split, comma, grid search CV. Train test split to divide the data set into train and test. Train, it will using for built machine learning, and test, it will check machine learning to know the accuracy for it. From scikit-learn.svm support vector machines, import SVC support vector classifier, because this case classification, not regression. From scikit-learn.matrix, import accuracy score classification report. From scikit-learn.preprocessing, import standard scalar for scaling the data. We will run the cell and we will create X and Y. X is independent values. Y is dependent, is the target. We will take all columns as X unless outcome, because outcome is target. X equal df drop outcome, X is 1 column, and Y equal df outcome. And we will run. We will split data into train and test. X train, comma, X test, comma, Y train, comma, Y test equal train test split, X, comma, Y, test size equal 0.1. 0.1, it means we will take 10% from the data as a test data, and we will use 90% from the data to build the machine learning model. Random state equal 0. Scaling data, scalar equal standard scalar. We create object for standard scalar. And xtrain equal scalar dot fit underscore transform xtrain. And also xtest equal scalar dot fit underscore transform xtest. Scaling the data. Run. We will define the support vector classifier model. SVC equal SVC. We will create object for this one. And we will set some hyperparameters to check and get the best accuracy. Parameter underscore grade will create a dictionary. C, many values 0.1, 1, 10, 100. And gamma also more than one value. And kernel, RPF, BOLY, sigmoid. And we have many parameters. We can check it and try to get the best accuracy. And we will run this cell. We will implement grid search CV to check these parameters and know which parameters will give me high accuracy for machine learning model. Grid search equal grid search CV SVC, which we defined here, comma, parameter grade we defined here, comma, refit equal true, vespro equal 1, CV equal 5. And we will fit the model grid search dot fit xtrain ytrain. And we will run this cell to check all hyper parameters and select the best one for highest accuracy. This process, it will take time. I will pause this video now and I will come back again when complete it. The process completed and create a grid search with best parameters, and we will check here the parameters. Best parameters equal grid search, which we created here, dot best parameter. and best model equal great search dot best estimator. We will run the cell. We will make a prediction using X test. Y predict equal best model dot predict X test. We will evaluate the model now with comparing the Y test with Y predict. Accuracy equal accuracy score Y test and comma Y predict, which we calculated here. And classification report equal classification report Y test Y predict, also compare. And we will print best parameters and the accuracy for test data and classification report. We will run. Here the accuracy for the model 84%. This is the highest accuracy for machine learning algorithm. I will put the link for this Jupyter notebook in video description, and you can download it.
Thanks for watching, and I hope this video was useful for you. If you like this video, please consider subscribing, and I hope to see you in next video.